Okay guys, so in this video we'll be taking a look at more exam style questions from the Core 1 Edexcel Algebra and Functions workbook, looking at exam style questions from the Edexcel C1 paper. And this particular set of questions is from the January 06 Edexcel Pure Core 1. As ever guys, feel free to pause the video, try and attempt the questions yourselves, and then come back and press play, and feel free to take any notes if you need to. This is question number 1. Factorize completely x cubed minus 4x squared plus 3x. So first of all, I can take out an x out of this cubic expression. So if I take out an x, I get x brackets. Well, x times x squared gives me x cubed, and x times negative 4x gives me negative 4x squared, and then x times positive 3 gives me 3x. I now recognize that this quadratic can also factorize. So I'm going to have x, and then I'm going to have two brackets, because it's a quadratic expression. To make x squared, I'm going to have x and x. I want two numbers that add to make negative 4 and multiply to make positive 3. So my only combination for that will be 1 and 3, so it'd be minus 1 and minus 3, because negative 1 subtract 3, or negative 1 add negative 3, I should say, gives us negative 4, and then negative 1 multiplied by negative 3 gives us positive 3, guys. So that is our final answer. Question number 5a, write the square root of 45 in the form a root 5 where a is an integer, so it's simplifying surds. So root 45, is equal to root 9 times root 5, A little clue here, because it's in the form a root 5, one of the numbers inside the square root symbol has to be a 5. 5 times what is 45? Well, 5 times 9 is 45. So root 45 is equal to the square root of 9 times the square root of 5. The square root of 9 is 3. 3 multiplied by root 5 is equal to 3 root 5, guys. So this topic is looking at simplifying surds, that some surds can be simplified, and it's knowing your factors of numbers, and particularly the highest square number factor that goes into that number. Now fortunately for this question, we were given the form it had to be in, so I knew that one of them had to be a root 5. So to work out the missing bit, 45 divided by 5 gave me 9. And I know that I can take the square root of 9. So that's like a little cheat way of like working out the other number in my square root, guys, But obviously, if it hadn't given you the form, then you would be expected to know what the square number factors are. And there's no harm in writing them to the side somewhere. Part B, express this in the form b plus c root 5, where b and c are integers, and it's a 5-mark question, so we have to rationalize this. Now, first of all, I'm going to expand the numerator, the bracket on the numerator, so I get 6 plus 2 root 5. That's all over 3 minus root 5. I'm now going to multiply top and bottom by 1, but in particularly, I'm going to multiply by 3 plus root 5 over 3 minus root 5, I'm multiplying by its conjugate, so I'm multiplying by the conjugate of this surd, and what that means is I'm multiplying the numerator and denominator by this, but instead of the minus sign, I put a plus sign. And the reason for that is it will become clear in a second, but if you're interested, on the denominator, I get the difference of two squares, hence why this works. Okay, so expanding this, I get 6 times 3 is 18. 6 times root 5 is 6 root 5. 2 root 5 times 3 becomes 6 root 5 again. And then 2 root 5 times root 5, okay, well, root 5 times root 5 goes to 5, times by 2 is going to be 10, okay, so we get 10 there, okay. On the denominator, okay, because it's a difference of two squares, I will get 9 minus 5 on there, because the middle terms end up cancelling out, okay, and knocking each other out, okay. So 3 times 3 is 9, 3 times positive root 5 is positive 3 root 5, then I get the minus 3 root 5, so that just goes to 0, minus root 5 times positive root 5 is minus root 25, which just goes to minus 5. Okay, collecting like terms, guys, and simplifying this, 18 plus 10 is 28, okay, 6 root 5 plus 6 root 5 goes to 12 root 5, okay, and then I'm going to get 9 minus 5, which is 4. Okay, I can now simplify this. 28 divided by 4 is 7, and 12 root 5 divided by 4 goes to 3 root 5. Okay, 12 divided by 4 is 3. Okay, so my final answer would be 7 plus 3 root 5. And I'm going to be very clear, guys, that you have to put your answer in this form. So although technically this is correct, okay, it wants it in the form b plus c root 5. So make sure that you are always checking back to the question and making sure that it's written in the correct form. I know I'm being picky here, but I've seen marks lost in the past where students have written it in like a different form. Okay, it wants it in the form b plus c root 5, where b is 7 and c is equal to 3. Okay, if you're interested. Okay, so that's rationalizing, okay, the surd. Okay, so it's rationalizing the denominator. Okay, so we multiply top and bottom by its conjugate, i.e. this, but instead of the minus sign, it becomes a plus. If it was a plus there, it'd be a minus there. Okay, on top and bottom. Okay, it's so we get the difference of two squares on the denominator of my fraction. Okay, so then I get a whole number on the bottom of my fraction. Right, guys, that's the end of today's short, sharp video. I sincerely hope you found it useful. I hope you found it informative. If you did, please press like, please subscribe to the channel if you're new, and lastly, please click that bell icon, okay, so you are notified of when I upload for the AS Pure Maths series, okay, and also GCSE Maths, and also the occasional Key Stage 3 and Key Stage 2 maths, okay, but that's it from me today, guys. Thank you so much for watching. Take care, stay safe, stay healthy, and I'll see you in the next one, okay, bye for now.